Welcome. Today we're going to be working with solving logarithmic and exponential equations. So the first major thing that we're going to do is we're going to use equal powers property. For b greater than 0 and not equal to 1, if b to the x equals b to the y, then x has to equal y. Because can you imagine any regular number other than 1 and 0 where when you raise this side to a power and it's equal to the same thing raised to some power? Can you think of any other power where it would be equal? No, they have to be the same. So if I have an example like this, 2 to the 4x minus 7 equals 2 to the 11, then 4x minus 7 has to equal 11. Oops. Do that again. 11. So now I just have to solve this. Add 7. 4x equals 18. Divide both sides by 4. And I get x equal to 4.5. That doesn't always come out nice and neat. 9 over 2 is 4.5. And there you have your answer. Equal powers property. Now use the equal powers property and solve each of these. Alright, hopefully you've done each of these. I'm going to give you the answers just to check. Before I do that, let's say the equation is 7x minus 4 equals 3. This equation is x minus 2 equals 5x minus 6. And the bottom equation is x plus 3 equals 4x minus 9. Those are your three equations. And if you didn't have that, now you do, and solve them. So the first one, x is 1, 1, and finally 4. So hopefully you got those. Here's the next example. What happens when the bases are not the same? Well, can I rewrite the bigger number as 6 in this case to a power? Yes. 6 to the second is 36 to the 8x minus 1 power. So I can say that 6 to the 4x plus 1 equals 6 to the 2 times 8x minus 1. Now I'm just writing it out like that. I know you could distribute it. Now what I'm going to do is now set the exponents, since the bases are the same, equal to each other. My fingers don't want to write today. I don't know if it's my brain or my hand. Here we go. So I have to, darn it. I have to distribute the 2 rather, the 2. 4x plus 1 equals 16x minus 2. Let's see, I'm going to subtract 4x from both sides. So that gives me 1 equals 12x minus 2. I'm going to add 2 to both sides. 3 equals 12x, and then divide both sides by 12. X is 1/4. Always try to reduce your fractions if you can. Alright, there's your answer there. Now, if we have a problem like this, where we have a variable, a number to a power that includes an exponent, a variable, yes. A number to a power, and the power includes a variable, and it equals a number, I can do something called taking the common log of each side. So I'm going to say log of 7 to the x equals log of 20. Now you may say, well, how does that get us anywhere? Remember I said when we were working with expanding and condensing log information, that it helps us manipulate it. Well, this power can now become the multiplier. And this is common log, which is what's on your calculator. Now, when we work with this, one of the things that we notice is that I can get rid of the log base 10 of 7 because it's multiplied times my variable. So I'm going to divide by log of 7. So I end up with x equals log of 20 over log of 7. Now that's an approximate symbol. Log of 20, I'm going to round this off, but 1.30103, let's call it that. And log of 7 is 0.845098. You don't have to go quite that far, but it is handy to do it fully out. And so let's round the final answer to 2 decimal places. Let's see. I want the divisor in first. And the answer is 1.54 if you round it to 2 decimals. And that's how you do take the common log of both sides. You solve that problem because you have a variable as your exponent. All right, give this one a try. See what you can do. All right, now I'm going to demonstrate this. Log of 10 to the 2x plus 5 equals log of 6. The exponent becomes the multiplier. 2x plus 5 times log of 10 equals log of 6. Now what's interesting, and a lot of people will miss it, I'm going to divide by log of 10. But what's interesting is, what's the log base 10 of 10? It's 1. So it's really gone, isn't it? So I didn't really have to do that step. So 2x plus 5 equals log of 6. Now over here, let's do that out. Log of 6. That's the log button on your calculator. 0.778. Let's round at 4 places too. So I'm going to subtract 5. And negative 4.2218, say, and divide by 2. X is negative 2.111. Just round that off. Good enough. In fact, even if I just did it 2 decimal places, which is an easy way to state, negative 2.11. All right, let's continue. Equal log property, equal logarithm property. If log base b of x equals log base b of y, then x has to equal y. So, key things here, the bases have to be the same and the 2 things have to be equal to each other. Well, our bases are the same of our log and they're equal, so 4x minus 3 has to equal x plus 6. And now I just solve. Subtract x. 3x minus 3 equals 6. Add 3. 3x equals 9. Divide by 3. X is 3. And there you have it. equal log property. Exponentiate. This is our last one. And this one is a little bit, unexpected. You recall, I think, that when you have something that has equal powers, the same base has equal powers, you can set the two powers equal to each other. Well, this is the reverse of that. I've got two things that are equal, and I'm going to say that they're the power, and I'm going to use whatever the base of the log is as my base. So I'm going to write a big 3, that's the base of this, log base 3 of 5x plus 1 equals big 3, and this is going to be the power. So these two become the powers, and this is the base of the power on both sides. Now I do that really large so it's easy to write it, but you don't have to write it quite that big. But just make sure it's big enough that it's obvious that this whole thing is your power. Now remember before, a couple of days ago, we said that when the base of the power and the base in the power of the log are the same, that is what it equals. So 5x plus 1 equals this side, and this side, 3 to the 4th power, I think that's 81. Yep, 81. And now I can solve for my variable. Exponentiate. I like that word. Subtract 1 from each side. 5x equals 80. Divide both sides by 5. X is 16. And there's your answer. Homework is in Google Classroom. I hope you have a great day.